Hello everybody, we're going to work on PEMDAS today with using fractions and decimals. This is what we're going to do today, working with PEMDAS and decimals. Let's work on PEMDAS using decimals. Hello. Let's find some exercises about this. Let's find some exercises about PEMDAS with decimals and fractions. Okay, I already found them. Okay, before working with PEMDAS with decimals, let's remember a little bit how to add or subtract mixed numbers. Then something about decimals, and finally some exercises using PEMDAS. This is the strategy of today. So, an easy exercise: 1 1/4 minus 3 5/8. 3 5/8. Going to do this exercise, this subtraction or addition of fractions. Remember that when you learn integers, now the addition and the subtraction becomes kind of the same operation, because adding the negative is the same as subtracting the positive. So you can see this like a subtraction of two numbers, or like the addition of two integers, because we're adding here a negative number, -3. Now, I suggest you always to start with estimating the answer. In the case of mixed numbers, let's estimate 1 1/4 to 1 minus 3 5/8. So 3 5/8, we're going to round it to 4, because 5/8 it's like greater than 1/2. So I'm gonna get 1 minus 4, and 1 minus 4 is gonna get me -3. Now remember that when you have two integers, and in this case 1 minus 4, if you imagine this on a number line, we get 0 here, then we get 1, like you can draw like an arrow, 1 positive, and now I'm going to draw -4. So it's going to be 4 units to the left. So this is like -4. So it means that the answer is here. Observe that you have to perform a subtraction, and the subtraction is -3 because it goes from right to left. So it's going to be -3. And you can use the general strategy that I did in a video, in which if you have two integers and you have different signs, in this case +1 and -4, so you must subtract the absolute values, in this case 4 and 1, 4 minus 1 is 3, and the sign comes from the highest absolute value, or the highest distance, in this case -3. Okay? Now I got the estimation. After I got the estimation, I'm going to perform my operation, and to perform my operation, I'm going to divide it in two parts. The first part is going to be the integers part. So I'm going to operate the integers, 1 and -3, 1 minus 3, in this case is -2, and I'm going to perform now the fractions part. The fractions part. Hey, I got here in my... Give me a minute. Let's change here, because it says adding integers, and I'm not adding integers. Let's write here. We are solving using PEMDAS. Okay. Hello. Hi, Mati. Okay, fractions. No, so I'm going to subtract the fractions, and in the part of fractions, I'm going to take just 1/4 minus 5/8. And remember that when you subtract or add fractions, you need common denominator. So we need to get the common denominator between 4 and 8. It's going to be 8. 8 is a multiple of 4. So multiply by 2, 4, and you're gonna get 2/4 minus 5/8. In this case, it's going to be -3/8. So finally we can get the answer, and in our answer this is gonna give -2 minus 3/8. So as both have the same sign, -2 minus 3/8, this could be just written as -2 and 3/8, -2 and 3/8. This is the way you can do this exercise. What happens if they don't have different signs? You need to use another strategy. Include one unit here. Include one unit here. So I'm going to do an example so you can see it. Just an example, but not the whole subtraction, because I want to focus on PEMDAS here. But what will happen if you have, let's put it here like in another color, like in a cloud. What would happen if at the end of your operations you got 5 minus, let's say 3/7? Let's say that you operate, you work out, and you get this answer, 5 minus 3/7, here in the part of answers. Both have different signs, or -5 plus 3/7. So what you must do, in this case, you must take one unit from this 5, so it's going to be 4 plus 1, but instead of 1, I'm going to put 7/7. 7/7. 7 divided 7 is 1, so a 7 divided 7 is 1. I can use 5 as 4 plus 7/7 minus 3/7. And in this case, so I'm gonna get 4 plus 7 minus 3 is 4/7. So it's equal to 4 and 4/7. You must apply this when you have different signs in your answer. If you have different signs in your answer, this is what you must do. This is what you must do. Convert it into 1. Okay, I just wanted to remember. How long is it? I don't know how long it's gonna take me to work out some exercises of PEMDAS. Good question. How long? I don't know. Okay, and finally, so this is like the idea of adding or subtracting integers. We're gonna get it like in our mind. Meanwhile, we work on PEMDAS. Now, other important part when you work with PEMDAS using decimals or fractions, or decimals or fractions or mixed numbers, is sometimes maybe you need to convert decimals into fractions, right? So we're going to convert a decimal into a fraction, or a fraction into a decimal. But usually, if you want to get 0.25, you have this decimal and you want it as a fraction, right? So just remember that a decimal is just a representation of a denominator who's a power of 10. So in this case, you must count how many decimal places you have. In this case, I have 2 decimal places. And these 2 decimal places just tell me that this number is 25 over 100, right? Because I have 2 decimal places. The number of decimal places tells me the power of 10. In this case, 100. So then in this case, if you're going to divide 25 divided by 100, just simplify by dividing by common factors. In this case, a common factor, it's 25. But let's imagine that I don't know that it's 25. Let's imagine that I know that it's 5. So 25 divided by 5 is 5. 100 divided by 5 is 20. Then 5 divided by 5 is 1. Then 20 divided by 5 is 4. So it's gonna give me 1/4. Okay? Or maybe you prefer to work if you prefer to use decimals. So you want to know this as a decimal, a fraction as a decimal. So let's say that we have the fraction, let's say that you have the fraction 3/4. And I want to know this as a decimal. I need to multiply this number 4 in order to get a power of 10. There are numbers like 4, like 2, like 8, like 5, like 10 that if you multiply them by a specific number, it's going to give you a power of 10. So I'm going to multiply 4 times 25. Hello? 4 times 25. So if you multiply 4 times 25 and 3 times 25, because I'm going to amplify the fraction, I'm going to get 75 over 100. And now that I have the power of 10, I just need to divide by 100, moving the decimal point twice to the left to get 0.75. Okay, so what I did was to take the decimal point, move it to the left twice because it says 100, and I got 0.75. This is the other part of converting, this is the other part of converting fractions to decimals. Or, oh, I want it as a percent. So remember that a percent is just a fraction over 100. So in this case will be 75 over 100, or multiply 0.75 by 100. You multiply 0.75 by 100, it's gonna give you 75%. So this is the percent. Okay, just ideas that you can have or you can use if you want to work with PEMDAS using decimals and fractions. Decimals and fractions. This is the main idea. Okay. So following these ideas, let's divide, for example, let's start with this division, 0.2 divided 5 quarters. So let's say that I'm going to divide 0.2 divided 5 quarters. So I suggest you to try to do it. How do you multiply or divide fractions by decimals? This is the idea. This is what we're going to do now. So observe that we have in this case a decimal and a fraction, but we already know how to convert a decimal into a fraction or a fraction into a decimal. So actually operating decimals by fractions is the same as operating a fraction by a fraction or a decimal by a decimal. You must choose which one is the one you're going to use. You must choose if you're going to convert the decimal into the fraction or the fraction into a decimal. This is what you must do. Okay. Give me a minute. Let's check some questions here. Okay. Let's answer here some questions. Give me a minute. Maybe you can observe how to do this exercise. Meanwhile, I'll answer here. So the idea in this exercise is that you convert or the fraction into the decimal or the decimal into the fraction. Which one do you prefer? Which one is better for you? Fraction into decimal or decimal into fraction? I prefer fractions. I prefer fractions. Okay, I have a lot of messages here to check. Okay. Let's do it. So I'm going to convert the decimal into the fraction and then I'm going to operate as fractions. Sorry. Let's go. So I'm going to convert it into fraction. This 0.2 I'm going to convert it into a fraction. So now I know that 0.2, I'm doing the study guide. These are the answers of the static and yes, the answer change if you don't simplify. You must simplify all answers. You must simplify the answers. So I'm going to convert this 0.2 into a fraction. 0.2 as a fraction is going to be 2 over 10. And if you want to continue, you can divide by common factors here. I can divide by 2. 2 divided by 2, 1. 10 divided by 2 is 5. So the answer is going to be 1 over 5. So this 0.2 is 1 over 5. So actually, this operation is just 1 over 5 divided 5 over 4. Now, how you're going to divide fractions? Remember that dividing fractions is the same as multiplying by the reciprocal. So what I'm going to do is just interchange numerator and denominator. So I have 1 over 5 times 4 over 5, and I got a multiplication of fractions. Identify if you have common factors between numerators and denominators before you multiply. In this case, there are no common factors between 4 and 5 here, so I cannot do anything, just multiply. 4 times 1 is 4, 5 times 5, 25. 4 over 25 is going to be the answer of 0.2 divided 5 over 4. Oh, but I require the answer as a decimal. As a decimal. Oh, I got this line. As a decimal. So if you need it as a decimal, find a number that you can multiply by 25 to get a power of 10. In this case, I already found, look at 25 times 4 is 100. So I'm going to multiply by 4. 25 times 4 is 100. And 4 times 4, 16. So I'm gonna get 0.16. Or if you want it as a percent, 16 over 100 means 16%. So you have the three options. Fraction option, 4 over 25. Fraction option, 4 over 25. Decimal 0.16 or 16%. You can convert it in any of them. Now this is just to operate fractions, decimals, fractions with decimals, these type of operations. Now what happens if you need to apply a little bit of PEMDAS? Like in this exercise. Let's say that you have this exercise, 0.1 times, and I need here to solve it to 1/1/3 minus 1 and 5/6. We have to work this one. Yes, it's going to be recorded. You can see it later at any time. Now, in this case, we have to apply PEMDAS to work it on. My suggestion, again, is like to try to estimate the answer first. Estimate the answer first. So if you estimate the answer, I'm going to estimate 0.120. I'm going to put just 0.1 times, this is going to be 2 minus, and this is going to be about 2 as well. Oh my God. So I got 0.1 times 2 minus 2. So if I estimate, remember that first parenthesis, 2 minus 2 is going to be 0. Oh my God. So my estimation gives me around 0. So the answer of this operation should give me around 0. This is the first thing I need to understand, that it's around 0. Now I'm going to perform the operation between the parentheses. Observe that the estimation also helps you to know what are the operation you need. Estimations will be mandatory in exams. Sometimes FABs, depending. Sometimes exam says that you must estimate. Sometimes exams don't say you estimate. So depending. I suggest you, anytime you can do it, I suggest you. It's not gonna take you more than 30 seconds to do it. So I suggest you to always try to do it. In this case, observe that first I do the parentheses, then I multiply the parentheses by 0.1. So first I'm going to get this parentheses. So I'm going to do the operation. I need to start with 2 and 1/3 minus 1 and 5/6. Let's perform the operation. So integers, the integers are going to be 2 minus 1, that is 1. Observe that I'm using the integers that correspond to the numbers, not the estimations. And fractions, so I'm going to do the fractions 0.2. No, I'm doing, if you're talking about the study guide, I'm doing exercise 2, not exercise 1. So the numbers now, it's going to be the fractions 1/3 minus 5/6. Again, you need to find the common denominator between 3 and 6. 6 is a multiple of 3, so the least common multiple is 6. I'm going to multiply by 2 this fraction. Amplify by 2, not multiply by 2. So you get 2/6 minus 5/6. This is gonna give me minus 3/6. And observe that here I got what I told you. Okay, but 3/6 is just, if I simplify, divide by common factors, 3 is a common factor, 6 divided by 3 is 2, so the answer is -1/2. So now that I have -1/2, I'm going to do 1, the integer, minus 1/2. Okay? In this case, observe that I just have one unit here. I don't have more than one unit. I don't have 20, I don't have 18, I don't have 50, I don't have 5. I have one unit here. I can multiply by 3. Yes, I can divide by 3 here, this fraction. Simplified by 3. Yes, I guess I understand what you mean. And finally, this one, I can write it like in terms of 2. So like 2/2 minus 1/2. 2 minus 1, 1/2. Look at that, my answer is 1/2. That is, it could be around 0. Okay? Which part you don't understand? Okay, write the question. Don't put me I don't understand, because I don't understand means everything, and I don't think you didn't get everything. I already have my subtraction of integers here, or my addition of integers here, and according to what I did here and according to the expression, I need to multiply this answer by 0.1. So I'm going to continue. I already did the parentheses. If you want, let's put here parentheses. Uh, 2 and 1/6. You got 2 and 1/6. Why did you get 2 and 1/6? I don't know why you got 2 and 1/6. The part of the fractions again, here. Okay, remember that you just need to take the fractions with the sign. 1/3 minus 5/6. Okay? Now, common denominator is going to be 6, because 6 is a multiple of 3. So just multiply by 2. 3 times 2, 6. 1 times 2, 2. Now, after you get this, perform the operation. 2/6 minus 5/6. So it's numerators. 2 minus 5, -3. -3/6. So I got -3/6. And now I'm going to simplify this fraction because I have common factors between 3 and 6. So divide by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. And I got 1 over 2. Column form. What happens if you use column form? No, the answers must be exactly the same. Must be the same. If you use column form, you must got exactly the same answer. Exactly the same answer. Cannot be different. If you want, I can do it in column form quickly. I must do it here. Yes, I'm gonna do it here. Column form. A parenthesis. I'm going to use another color, purple. If you use column form, in this case, I'm going to put both mixed numbers, 2 and 1/3, in a column with 1 and 5/6. Now, if you use column form, first denominators must be common denominators. So if you use column form, just multiply by 2 here. So you have common denominator. Need to check that the space is appropriate. So you get 2 over 6, and here 1, 5 over 6. If you use column form, the numerator of the column, of the first row of the column, must be greater than the numerator of the second row of the column. In this case, they are not the same. The numerator is less than. So I need to give 1 unit here, like when you in Spanish you say prestar. So like when you give 1 unit here, and this unit is here 6 over 6. So 6 plus 2, 8. So if you use column form, the subtraction you need to do is 1, 8 over 6, and here minus 1, 5 over 6. This is the strategy of column form. Now I can subtract, because numerator of the upper part of the column is greater than the numerator of the part that is below in my exercise. Now I can subtract. 1 minus 1 gets me 0. 8 minus 5 gets me 3 over 6. Now if I simplify 3 over 6, I know that is 1/2. This is how to do it in column form. The answer is not 1 and 1/2 because they have different signs. This one is positive and this is negative. So you need to give 1 unit, 2 over 2, to subtract the unit. Okay? No, I haven't started study guide number 3. You want me to do a study guide number 3? Okay, so I'm going to erase this part. Let me see if it's not taking me too long to erase it. Because I haven't finished. I just did the parentheses. So I need to multiply this parenthesis, that is 1/2, times 0.1. So 0.1 times 1/2. And to do it, I need to convert or the decimal into fraction or the fraction into decimal. So I'm going to convert the decimal into fraction. 0.1 means 1 decimal point. So it's 1 over 10 over 1/2. There are no common factors between numerators and denominators. Be careful, even that there are common factors in denominators, you don't simplify it because both are denominators, and multiply. So this is gonna give me 1 over 2 times 10, 20. 1 over 20. This is the answer of this exercise. Okay? And this is how you can apply kind of PEMDAS when you work on this type of exercises. Okay. Let me answer some questions here. No, the answer is not 1 and 1/2. Again, 1 minus 1/2. It's not going to be 1 and 1/2. They're asking me what happens if you have a fraction. If I have a mixed number and I want it into a fraction. This is like anything that is before all of this. But let's do an exercise, a very quick exercise. Remember that the mixed number is just that you have a whole number added with a fraction. Added with a fraction. So if you have this mixed number, 3 and 5/6. This is just 3 plus 5/6. Okay, if you imagine this, 3 plus 5/6. This is why when you have 1 minus 1/2, you cannot write it as 1 and 1/2 because you're not adding the 1/2 to 1. Okay? You have two different signs. You have two integers with different signs. You cannot add the distances. But if you have minus 1 minus 1/2, then you can write it as minus 1 and 1/2 because as both signs are the same, you add the distances. Okay, now how to convert it? How to convert? Okay, study guide 2.1, study 1 guide. Okay, give me a minute. Now, to convert it, you just need to multiply 6 times 3 because it's like having this whole number as a fraction over 6. So if you want it as a fraction over 6, you multiply by 6. So 6 times 3, 18. Let's put it times plus. So 6 times 3, 18 plus 5 over 6. So this is like 23 over 6. But if you can see it in this way, or you can see it, you can understand why this is the operation. Why this is the operation? Because this 3 can be seen as 3 over 1. And if I want common denominator, I need to multiply by 6. And this is going to be 18 over 6 plus 5 over 6. Look at, this is what I'm doing here. 6 times 3, 18 plus 5. Okay, this is the way to see how you convert mixed numbers into fractions. Okay, they're asking me here from the guide. Question point 2, question 1. I just did it. Point 2, question 1, I just did it. Or not? Did I do other? 1 and 1/4 minus 3 and 5/8. Okay, let's do it. Let's do it. 1 and 1/2. I don't understand. I guess that you still with the problem of you got 1 minus 1/2. Why this is not 1 and 1/2? Correct? This is your question? Meanwhile, I wrote the other exercise that they asked me. This 1 minus 1/2 is not 1 and 1/2 because the mixed number includes here a positive, a plus, 1 plus 1/2. Okay? 1 plus 1/2. When you put 1 and 1/2 as a mixed number, 1 and 1/2 as a mixed number, what you're saying is that this is 1 plus 1/2. But here I have 1 minus 1/2. They don't have the same sign. Okay? No, I mean, I'm putting an example. What happened? Why I got subtracting in the last exercise is because you got, if I'm not wrong, you got 2 over 6 minus 5 over 6. So 2 over 6 minus 5 over 6 2 minus 5 is negative 3 over 6. And if you simplify it, you got negative 1/2. This is why. And the whole numbers are not negative, are positive. Maybe if I do this exercise, you can understand it. Maybe if I do this one, you understand. Let's see. Let's have some time to work. Okay, I got this exercise 1 1/4 and 3 and... is there a chance I can move something or not? No, I think I have to rewrite it. Okay, so 1 1/4 minus 3 5/8. I don't know if this is the exercise you asked me to do it. Okay, I'm gonna do it quickly. I'm going to use the estimation first. So the estimation is going to be 1 minus 3 5/8 is going to be 4. So the estimation gonna give me negative 3. And now I'm going to use integers. So 1 minus 3, that is negative 2. And then I'm going to use the fractions. Fractions are going to be 1/4 minus 5/8. Hey, I guess I did it. Yes, I did it already, but I'm repeating. Okay. 4 and 8 are common factors. 4 times 2, 1 times 2. I got 2 8s minus 5 8s. 2 minus 5 is negative 3 8s. Okay? So it means that the answer is negative 2 minus 3x. Now look at that. In this case, both signs are the same. Both signs are the same, so I can rewrite my mixed number. Okay? Just in the case that you have it in the same sign, you can do it in the same sign, you can put it as a mixed number. Ah, now I understand. You were asking me to do it in column form. I'm sorry. So I'm going to do it in column form here. Let's erase it and do it in column form. You want to do it in column form. Now, every time you operate in column form, decimals, fractions, mixed numbers, whatever type of numbers you want, your decision must be to put in the upper part of the column the highest distance, the highest absolute value. In this case, the highest absolute value is this number, 3 5/8. It's negative, yes, so put it first, negative. Negative 3 5/8. And then you put the other number, 1 1/4. Now, as both have different signs, we're going to perform a subtraction and the answer must be negative. So this is what we're going to do when you operate in column form. I need to have common denominators, so I'm going to multiply by 2 to get common denominator 8. So negative 3 5/8 plus 1 and 2 8s. So now I'm just going to operate. Negative 3 plus 1, only the... verify that the numerator of the upper part of the column is greater than denominator below. In this case is greater, 5 greater than 2. So now I'm going to perform my operation. Remember that we're subtracting and keeping the sign, the negative sign. So 3 minus 1 is 2, but it's going to be negative 2. 5 minus 2, 3. Okay? The advantage with column form is that in column form, if you operate correctly using column form by keeping the strategy of highest numerator up and highest number up, you can get always the final answer as a mixed number, and you don't have to do the part of giving one unit. Okay, if it's subtraction, usually this is not going to happen, usually not the rule, but this is the idea. The idea is that you can get a higher number up, so when you perform the subtraction you get the answer. Okay, this is column form. I also see another question from the guide I sent. Point 2, it says point 2 of study guide 3. Okay, I'm going to do point 2 of the study guide 3. Let's work on a little more time, 10 minutes. Point 2 study guide 3. Okay. Operations with decimals. Okay, how to operate decimals? How to operate decimals. Okay, but we're talking about PEMDAS. Let's do PEMDAS. Let's do PEMDAS. I'm going to do this one. But you tell me point 2. No, I want to do point 2. Let's work with this. 2.5 plus 1.75 minus 0.6. Okay, this is just addition and subtraction of decimals. Remember that addition and subtractions of decimals, you must align the decimal point. Okay, you must align the decimal point. Okay, I'm answering here questions. So you must align the decimal point. Now imagine that we are learning how to operate with decimals, and we have more than 2 decimals to add, so I suggest you to divide it in parts, to do it from left to right. Okay, so I'm going to explain this, then we're going to do another multiplication and division of fractions. In this case, so I'm going to use just this operation first, and then the answer I'm going to subtract it by 0.6. 0.6. So 2.5 plus 1.75. Observe, I'm using column form, and as I'm learning how to use decimals. Even that I'm using column form, I'm going to put the highest distance up. Okay, now I need to complete my decimals with zeros if I want to perform the addition. To add 5 plus 0 is 5, 7 plus 5 12, 2 plus 2 4, 4.25. So the addition of these two is 4.25. Now I'm going to do an estimation very quick. This is 3, this is 2, so the estimation of these two is 5. So yeah, okay, 4.25 is around this number. Now 4.25 must be subtracted to 0.6. Now if you're going to use column form, again, highest distance goes first. So I'm going to put the highest distance here. 4.25 minus 0.6 and complete with zeros. So 5 minus 0 is 5. I cannot subtract 2 minus 6, so I'm going to carry on here 1 to give 12 minus 6, that is going to be 6, and here is going to be 3. So the answer Look at that, this is 5, this is kind of 1. So the answer must be 5 minus 1, that is around 4. Okay, so 3.65. 3.65. This is how you can operate. What happens if you have a multiplication? What happens if you receive a multiplication? They put you a multiplication. What I suggest you is to estimate the answer. Estimate the answer. So for example, let's say that you have 4.8 times 5. Let's do a line here. 4.8 times 5. Now, I suggest you to estimate the answer first. I'm going to do it with blue. This 4.8 is around 5 times 5. So this is going to give me 25. Now, I'm going to multiply my numbers. 5 times 48. If you want, forget the decimal point for a minute. Forget it if you want. 5 times 8 is 40. 5 times 4 is 20. And 4, 24. Okay? If I forget the decimal point, 48 times 5 is 240. But I know by using my estimation that the answer is 25. So I know that the decimal point goes here to get 24.0 or 24. So your decimal point matches your estimation. Matches your estimation. This is a good idea because sometimes people, for example, in this case, they try to put the decimal point, but they say, but zeros to the left doesn't count. So they don't put the 0 and they put 2.4. So if you estimate, it's going to be easier for you. It's going to be easier for you. Okay, I'm asking here. I'm asking here something. I'm answering questions. Yes, they're asking me here, can you do an example? For example, if I have 1 minus 4, 6, I have a minus sign. We're still in mixed numbers. Okay, let's go back to mixed numbers. So they're asking me 1 minus 4, 6. What happens if as an answer I got 1 minus 4, 6 and I want to get the final answer as a mixed number, right? Now, here, what I suggest you to do first is simplify the fractions. Every time you have a fraction, try to simplify it all time. Divide by common factors. In this case, the common factor is 2, right? So 4 divided by 2 is 2. 6 divided by 2 is 3. So I'm going to get 1 minus 2 over 3. Okay, this is the first part. Now, after you have your fractions in simplest form, and you have a1, this unit, I'm going to put it as a fraction whose denominator is 3. So in this case, I'm going to put it as 3 over 3 minus 2 over 3. So 3 over 3 minus 2 over 3 is going to be 1 over 3. And this is why I cannot put that this is 1 and 4/6. I cannot put it this way, because I'm taking the whole and subtracting a part. If you have the whole adding one part, in this case 2/3, now I need to put 1 and 2/3. So if you have the whole with a different sign, you must perform the operation. Okay? Why 3 over 3? Because 1 is the same as 3 over 3. If you take 3 divided 3, you get 1. This is why you put 3 over 3. Let's say that you got, I don't know, 20 and minus 2 over 3. So from this 20, I'm going to take only one unit. That is 3 over 3, 1 unit. But this unit will be added with 19. 19 plus 1 is 20. And 1 is 3 over 3. 19, 3 minus 2, 1, and 1/3. Okay? This is what you put, 3 over 3. 3 over 3. Because 3 divided 3 is 1. This is something pretty cool, that when you are able to find out zeros and ones when you cannot see it, like in this case. So 3 over 3 is a 1. Can you do 0.4 of the static guide 3? 0.4. 0.4. Okay, this is PEMDAS. Somebody was asking me about division and multiplication of fractions. So I'm going to do, from 0.4, I'm going to take the second part that has multiplication and division of fractions. It says 5 quarters divided 0.5. 5 quarters divided 0.5 plus 2.75. 2.75. Okay. So the final answer is 1/3. Yes, the final answer is going to be 1/3 in the last question, right? Last question, yes. 1/3. 1/3, yes. 1/3. Okay, so we're going to apply PEMDAS, and in this case we have fractions and decimals. So you need to decide which side you're going to take. If you're going to take the side of fractions or the side of decimals. This is the idea. Side of fractions or side of decimals. So in this case, okay, I'm going to take the side of fractions because they were asking me if I can do another example of division of fractions or multiplication of fractions. So I'm going to convert 0.5 as a fraction. 0.5 as a fraction. So 0.5 as a fraction, I know that many of you could know how much is it, but we're going to practice the strategy. In this case, 0.5 as a fraction, I have one decimal place. One decimal place. So it means that this is the same as 5 over 10. Now, remember, take fractions and simplify it before you continue. So 10 over 5, I'm going to simplify, divided by 5, 1. 10 divided by 5, 2. So the answer is 1/2. Okay, maybe you know it already. So what I need to do is 5 quarters divided 1/2 plus, I'm going to leave this as a decimal. Okay. So, PEMDAS. In PEMDAS, multiplication and divisions goes first. It doesn't matter the order. What happens if you have 2.75 plus 5 quarters divided 1/2? So you don't do first this. You first divide. So if you apply PEMDAS, first the division. But dividing a fraction is multiplying by the reciprocal. So I'm going to interchange numerator and denominator to convert it as a multiplication. 5 quarters times 2 over 1. If you want, put here plus 2.75. Now I'm going to simplify this operation. 5 quarters times 2 over 1. Identify common factors. So I have a common factor here between 2 and 4. The common factor is 2. So I'm going to divide by 2 to get 1. Divide by 2 to get 2. And I'm going to multiply. 5 times 1 is going to be 5. 2 times 1 is going to be 2. Plus 2.75. Okay? So in this case, we're practicing how to add these parts. Now we have two options. The two options are, or you convert this into a decimal, or you convert this into a fraction. It's up to you. Which one do you prefer? Write me in the box section. Which one do you prefer? Fraction to decimal or decimal to fraction? I'm gonna give you 30 seconds to think, or I choose. 30 seconds to tell me fraction to decimal or decimal to fraction. Which one do you prefer? Fractions. Okay, here they're telling me fractions. 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 Decimal to fraction. Okay, let's practice decimal to fraction. If I want to do decimal to fraction, so I'm going to put 5 over 2 plus, and I need to convert 2.75 into a fraction. So how to convert it as a fraction? 2.75 has 2 decimal places. So it means that this is 275 over, and 2 decimal places means 2 zeros here. So it's over 100. 275 over 100. Now, if you want to work out with simplest form, so find out simplest form. Rules of divisibility. N at 5, N at 0. So I'm going to divide by 5. If you divide by 5, you're going to get, you're going to simplify this fraction. So if I divide by 5, I'm going to get 20 here. And if I divide by 5 here, I'm going to get 5 and 5. 55. 55 over 20. Look at that. I can continue dividing by 5. So I'm going to divide by 5 again. 20 divided by 5 is 4. 55 divided by 5 is 11. So actually 2.75 is just 5 halves plus 11 quarters. Okay? This is practicing how you simplify a fraction. And now, to add these two fractions, I need a common denominator. Look at that, this is 4 and this is 2. This is why I suggest you to simplify the fractions. Because this 100, instead of getting the common denominator between 100 and 2, I have the common denominator between 4 and 2. That it's easier, because it's just multiplied by 2. 5 times 2 is 10. 2 times 2 is 4. Plus 11 over 4. 10 plus 11 is 21 over 4. And I already have my answer. I want it as a mixed number. Remember that you can find this as a mixed number if you find the number, the multiple of 4 that is closer to 21. In this case will be 20. So 20 over 4 plus 1 over 4, right? And 20 over 4 is 5. So it's going to be 5 wholes. Oh, I don't have more space, right? 5 wholes and 1 quarter. Okay? This is if you use fractions. What happens if you use decimals? So convert to 5 halves into decimals and then perform the addition. Perform the addition. I'm gonna do it here. Why do you multiply by 2? Because I need a common denominator here. I have 2 and 4. I need the common denominator. So I need to amplify my fraction multiplying by 2. 2 times 2 is 4. 5 times 2 is 10. This is why we multiply by 2. If you want to do it as decimals, I'm going to go to the left. Oh God. I'm going to the left to do it as decimals. So 5 halves as decimals. I want to put it as decimal. If I want it as decimal, I need to multiply 2 to get a power of 10. So I can multiply 2 times 5 to get a power of 10. 5 times 5, 25. 2 times 5, 10. And I have 25 over 10. So remember that divided by a power of 10 is moving the decimal point to the left once. So in this case, I need to move it here, 2.5. So actually, this operation is 2.5 plus 2.75. Okay? And I'm going to add using column. 2.5. No. If if I want to do it in the way I'm showing you, I'm going to put the highest absolute value, that is 2.75. 2.75 plus 2.5 so I got 5 completed, 12, and 2 plus 2, 12, and 5. 5.25, that is the same as 5 and 1/4. How I converted into mixed number? The 21/4 over to a mixed number. The way I converted in this case was just by writing the one of the fraction. Yes, 21/4 to mixed number, right? This is what you mean. This number as a mixed number. Yes. I got 21/4. I don't know where to write. I don't have more space. Need to erase it. Okay, I'm gonna do it here. Let's erase this. You get 21/4. Now, one option is that you divide 21/4. So perform the division, 21 divided 4. This is one option. 21 divided by 4. So if you divide 21 by 4, you're gonna get 5 here. 5 times 4 is 20. 21 minus 20 is 1. So you got 5 wholes, and 1/4. This is option number 1. Now, let's say that you don't want to divide. You can rewrite 21 in terms of a multiple of 4 adding another number. 21 is 20 plus 1. 20 is a multiple of 4. So I can rewrite 20/4 plus 1/4. 20/4 is 5. 5 and 1/4. Option 2. 4 whole number 1/4 times. What happened with the 4 whole number? We multiply it with the result or what? You mean what happened if I have a multiplication of a mixed number? A mixed number. Okay, I'm going to erase this. Okay, let's finish with multiplication of mixed numbers. Let's say that you have the operation 4 and 1/4 times but I'm not going to put your example 2/5. I want to put another example. Let's put 2/9. Okay, yes, 2/3, 2/3. What to do if you have a mixed number times a fraction? If you have a mixed number times a fraction, you don't multiply it like fractions with fractions, wholes with wholes. This applies for addition of mixed numbers, not for multiplication. If you have a multiplication of a mixed number times a fraction, you must convert the mixed number into an improper fraction. This is the only way. There are other ways, but okay, this is the way you can practice when you're a beginner. There are other strategies that you can use it, but we're not going to use it here. Now, this is the idea. I'm going to convert this into improper fraction. How to convert it? Multiply and add. So 4 times 4, 16 plus 1/4 times 2/3. 16 plus 1 is 17/4 times 2/3. My mental math didn't work in something, but there's no problem. Okay, now you can perform the operation. Now you can think of multiplying. Do not multiply here like I multiply the fraction and then I put the 4. Don't do this because you're not adding mixed numbers, you're multiplying mixed numbers. Here, find common factors. Common factor is 2, for example, and 4. And now, after you operate all common factors, multiply the numbers. 17 times 1 is 17, 3 times 2 is 6. And if you need it as a mixed number, so convert the answer as a mixed number again. 17 over 6, I'm going to convert it as a mixed number. So I'm going to find out a multiple of 6 that is less than 17 and closer. In this case is 12. So I can write 17 as 12 plus 5 over 6, or 12 over 6 plus 5 over 6. 12 over 6 is 2. So the answer is going to be 2 and 5, 6. Okay? This is how you multiply mixed numbers by fractions. Or if you have two mixed numbers, convert the mixed numbers into fractions and multiply them. This is the way to do it. Do not multiply fractions and multiply wholes. This is not the way to do it. Okay, I want to add with a question that they sent me here by chat. They're asking me what happens if you multiply 3 fractions. What happens if I multiply 3 fractions? So I'm going to put you an example. 21 over 16 times, let's say that the other is 20 over 27 times, and let's say there is still a long way to go before it ends. I don't understand this message. And finally 45 over let's put 28. Okay. But I don't understand your question. There's still a long way to go before it ends. You mean the answer converted as a mixed number? It's not mandatory itself. Sometimes in some exams and some activities, they're asking you to put your answer as a mixed number. So if it says put your answer as a mixed number, so it's mandatory to convert it. But if it doesn't say write your answer as a mixed number, means that it's not mandatory. Okay? Now I'm just going to do this exercise and I leave. That's it. Okay, what happens if you have 3 fractions multiplied? You can use 2 options. First option is that you operate these fractions, these 2, and the answer multiplied by this fraction, and that's it. But as this is a multiplication, you can just find out common factors at any place. So identify common factors. This is the idea of multiplying fractions. So I'm going to identify common factors. Tell me if you identify a common factor here. A common factor between any numerator and any denominator. Let's see, I'm going to give you 30 seconds to send me a message telling me any common factor that you find out. Any common factor. I already find one. For example, I found here that I can divide by 4. So I can divide by 4, 20 and 16. Both share the common factor 4. So I'm going to divide by 4. 20 divided by 4 is 5. 16 divided by 4 is going to be 4. Okay? Now you can observe, try to find out more common factors. Maybe you identify another common factor by 2 as well. Yes, I divided by 4, but by 2 you can divide it. Identify another common factor. Any numerator with any denominator. Any numerator with any denominator. You can do it with any numerator and any denominator. For example, between 27 and 21, I have a common factor that is 3. So I'm going to divide by 3. 21 divided by 3 is 7. 27 divided by 3 is 9. Okay? Continue trying to identify common factors. Maybe if you want, you can multiply these two. Now you have the fractions here and then continue. But I'm going to keep it this way. Now I'm going to identify any other common factor. For example, here I have 45 and 9. Both are divisible by 9. So I'm going to divide by 9. 9 divided by 9 is 1. 45 divided by 9 is 5. Try to identify more common factors. I can see another. I can divide 28 and 7. 28 is divisible by 7. So it's going to be 7 divided by 7, 1. 28 divided by 7 is going to be 4. Now, I don't have more options. 5 and 5 are numerators, 4 and 4 are denominators, so they don't, even that they have common factors, I cannot divide them because both are numerators or both are denominators. So I just need to multiply 5 times 5, 25, 4 times 4, 60. Okay? And you need it as a mixed number, so you can use the strategy I was showing you. Like, I'm going to write 25 as the addition. Yes, look it. I can find, as long as it's one numerator and one denominator, I can use common factors. What I cannot do is if both are numerators. Okay, but one numerator and one denominator, you can continue with common factors. Yes. Yes. Or if you feel safe, you can do the multiplication of these two fractions, the answer, and then multiply it by this one. Okay, you can work out with both options. I can show you that it's the same, that is gonna lead you to the same answer. Look, I'm gonna do it in this way. First multiplying these two fractions and then multiplying by this one. So 21 over 16 times 20 over 27. So I'm going to divide by common factors. Divide by 4. 16 divided by 4, 4. 20 divided by 4, 5. Divide by 3. 21 divided by 3 is 7. 27 divided by 3 is 9. Look. So imagine that I'm going to do it just the first fractions, then multiply it by the other. 7 times 5 is 35. 9 times 4 is 36. Times, and now I'm going to use the other fraction, 45 over 28. So I'm going to divide again. So I'm going to divide by 9. 36 divided by 9 is 4. 45 divided by 9 is 5. And then divide by 7. 28 divided by 7 is 4. 35 divided by 7 is 5. You see? The answer is going to be the same. The same. And if you want it as a mixed number, you can use the strategy of rewrite 25 over 16 as 16 over 16 plus how much is left from 16 to 25, that is going to be 9 over 16, and you're gonna get 1 whole and 9 over 16. Okay? And this is like a review of how to operate, how to use PEMDAS, how to use fractions, how to use decimals, how to operate them. This is the part of decimals, fractions, integers, mixed numbers. This is kind of the whole deal. I hope that it helps you this time here working in these type of exercises. working on this exercise. I can see that somebody wrote me here 21 and 7 by 7. Good. And I hope that this helps you for your studies and that you get the most of it. I'm going to leave right now. Thank you for being during this session. Thank you for your questions and see you in another time. Bye bye. See you. Bye. Enjoy your evening. Remember that if you're studying for the exam, if you're studying for an exam, it's good that you sleep well before the exam. So I suggest you that tomorrow you have an exam, today sleep well. Okay? If you didn't study for 3 months, it's better, highly recommended, that study. If you need to study a little bit, study a little bit, but have health in your sleeping. Sleep early. Try to sleep well. Try to wake up in the morning rested, completely rested. Try to have fun before going to sleep. Okay? Try to relax before going to sleep. Let your brain connections to work on. So to prepare for the exam, sleep well. Whatever is the thing you didn't study before, I don't think you can study it during one night. It's not recommended at all. At all. So if you're going to study a little bit more, study half an hour, 1 hour more, and then go and sleep. Try to sleep well. It's very important to sleep well. Bye bye. Have a nice day. See you.